Friends, this is G. Lohit from SRIT, second BTech, studying in mechanical engineering. Today I wanna explaining about the problems on thin cylinders. It is one of the topic in mechanics of solids. So let's move forward to the topic. So I wanna explaining about the one of the problems in thin cylinders. So you have to understand it. So I wanna reading the topic. A thin spherical shell 1 meter in diameter with as well as of 1.2 centimeter thickness is filled with the fluid at the atmospheric pressure of what intensity of pressure will be developed if of 175 centimeter cube more of the fluid is pumped into it. Also calculate the circumferential stress at the pressure and the increase of diameter. So I am reading the question one more time and listen carefully. A thin spherical shell 1 meter diameter with as well of 1.2 centimeter of thickness is filled with the fluid in atmosphere. So here they given the one thin spherical shell. It has the and they are saying about it has the diameter of 1 meter and as well of it has the thickness of 1.2 centimeters and it is filled with the fluid in the atmospheric pressure. So they given the pressure also with the intensity developed in that spherical shell was 175 centimeter cube and more fluid filled and they are also saying that after the 175 centimeter cube also more fluid also pumped to it. So now they are asking to us what calculate the circumferential stress and pressure in the increasing the diameter. So and they also given the e value is 200 giganewton per meter and 1 by m equals to 0.3. So let's go to the further in the topic. So diameter of the spherical shell was d equals to 1 meter and the thickness was of the wall is t equals to 1.2 centimeters. So you can convert into meters. So when we convert into meter it will be equals to 0.012 meter and volume of the fluid delta V equals to 175 centimeter cube. When we convert into it meters, once we can write as 175 into 10 to the power of minus 6 meter cubed. And they are asking calculate the increase of diameter. So before calculating the increase of diameter, we can calculate the volumetric strain to derive it. So what is the formula of volumetric strain? Delta V equals to V. So they are given the change in volume. That volume is called 175 into 10 to the power of minus 6. So V formula, volume formula, pi by 4 into d square by L. So you can write as 4 by 3 pi into 0.5 square and equals to, when we calculate these values we can get the value of 0.000334. Okay, next we can by this we can calculate the EV equals to 3V. So by these we can calculate the modulus of elasticity. We can take the the left side and EV delta V EV by the right side by 3. So volumetric strain value, when here we get it 0.000334 by divided by 3, then we get the value of 0.00111. By this we can calculate the we can calculate the change in diameter value. E equals to delta dy equals to delta d by d. So next page, E equals to delta d by d. What we need? Delta d. So we can take the delta d this side and E into d. So E value is 0.0000011 into diameter value they given the one. When we multiply this, we get the same value of 0.00011 meters. So we have to convert into mm. We can write as 0.111 mm. Hence the increase of diameter equal to 0.111 mm. So now they are asking to calculate the circumferential stress by using the relation of E equals to sigma C by E into divided by 1 minus 1 by m. By this equation we get the circumferential stress. So what is the value of E? 0.000111 equals to sigma C divided by what is the value of E they given in the question, equals to 200 into 10 to the power of 9 into 1 minus what is the 1 by m, 0.3. So now take the sigma C left side, and by this it converts as 0.0111 into, and E value comes upside, and it will be multiplies with 0.0111 into 200 into 10 to the power of 9 by 1 minus 0.3 equals to 0.7. By this calculation we can get the value of circumferential stress. What it is? 31.314 into 10 to the power of 6 Newton per meter. When we convert these values into the mega Newton, it will be as 31.314 mega Newton per meter square. So next they are asking to find the pressure. By they told in the problem, no, they are added the additional fluid. By this we can and asking to calculate the another pressure. So we can have the pressure value also, sigma C equals to PD by 40. By using this equation we can get the pressure value. So we need the pressure value, so take the P this side, and sigma C into 40 by D. So sigma C, circumferential stress, we get in the value of 31.314 into what is the value of 4 and into 4 into, and T value thickness 0.012 divided by D 1. So by this after this calculation we can get the value of 1.522 into 10 to the power of 6 Newton per meter, this pressure. When we convert this value into mega Newton, we can get the value of 1.522 mega newtons meter square. So by these equations we can calculate the circumferential stress and pressure values. And next, thank you for watching. Have a nice day.